Paint on busbars is a potential concern because it can introduce contamination and affect the electrical performance of the panel. The contamination factor will depend on the type of paint used and its thickness. Oil-based paint has a higher contamination factor due to its non-conductive nature. It can create a layer of insulation, increasing the resistance and reducing current flow. Water-based paint has a lower contamination factor, but can still affect conductivity if applied excessively. Paint contamination can be cleaned off using appropriate methods without compromising the integrity of the busbar. For oil-based paint, use a solvent or paint remover designed for that type of paint. For water-based paint, use a mild detergent and water. Painted busbars should not be considered safe until they are properly cleaned and inspected. Paint can reduce the conductivity of the busbar, potentially leading to overheating and potential electrical fires. Paint can initiate or sustain arcing faults, which can cause serious damage and safety risks. Water-based paint is generally considered less hazardous compared to oil-based paint, but still requires proper cleaning. If the paint layer is thin and does not significantly affect conductivity, it may be acceptable to leave it on after cleaning. However, thicker or uneven layers of paint should be removed to ensure proper electrical performance and safety. It is important to assess the specific situation to determine the severity of the contamination and the appropriate cleaning method. Manufacturers' recommendations and industry best practices should be followed. Ensure proper ventilation during cleaning to avoid exposure to harmful fumes. Use non-abrasive cleaning methods to prevent damage to the busbar surface. Inspect the busbar thoroughly after cleaning to confirm that all contamination has been removed. If there is any doubt about the integrity of the busbar, it should be replaced. Now let's look more closely at the topic. When paint contaminates busbars, a few things can happen, affecting how well the electrical panel works and how safe it is. Firstly, oil-based paints act as insulators. Because oil-based paints don't conduct electricity well, they can form a barrier that reduces the flow of current. This can lead to higher resistance in the connection, causing the busbar to heat up more than usual. Secondly, water-based paints still pose risks. While water-based paints are less problematic than oil-based ones, they can still affect how well electricity flows, especially if there's too much paint. Thirdly, cleaning is crucial for safety. Removing the paint carefully is important to ensure the busbar works as it should and to prevent any safety hazards. When cleaning busbars contaminated with paint, you can follow a step-by-step process to make sure it's done correctly and safely. 1. Preparation is key. Before you start, turn off the power to the electrical panel to avoid any shocks. Wear safety glasses and gloves to protect yourself from chemicals and paint particles. 2. Identify the paint type. Figure out whether the paint is oil-based or water-based, as this will determine the type of cleaning solution you need to use. 3. For oil-based paint removal, use a solvent or paint remover that's designed for oil-based paints. Apply it to a clean cloth and gently rub the painted areas. Avoid pouring the solvent directly onto the busbar. 4. For water-based paint removal, mix a mild detergent with water. Dampen a clean cloth with the solution and gently wipe the painted areas. 5. Avoid abrasive materials. Don't use steel, wool or other abrasive materials that can scratch the surface of the busbar. 6. Ventilation is essential. Work in a well-ventilated area to avoid inhaling harmful fumes from the solvents or paint removers. 7. Inspect thoroughly. After cleaning, check the busbar to make sure all the paint has been removed. Look for any signs of damage or corrosion. 8. Test conductivity. If possible, use a multimeter to test the conductivity of the busbar and make sure it's within the manufacturer's specifications. 9. Reassemble with care. Once you're satisfied that the busbar is clean and in good condition, carefully reassemble the electrical panel. 10. Professional consultation. If you're unsure about any part of the cleaning process or if the busbar is severely damaged, consult a qualified electrician. They can provide further guidance or replace the busbar if necessary. When evaluating safety, keep electrical hazards in mind. Paint that reduces conductivity can lead to overheating, increasing the risk of electrical fires. Also, Be aware of arc hazards. Paint can cause arcing faults, which can result in significant damage and pose safety risks. Water-based paints are generally safer compared to oil-based paints, but proper cleaning is still necessary. If a thin layer of paint doesn't significantly impact conductivity, it might be acceptable to leave it after cleaning. However, thicker or uneven paint layers should always be removed to guarantee proper electrical performance and safety. Always follow manufacturers' recommendations and industry best practices when dealing with busbar maintenance. Ensure adequate ventilation during cleaning to avoid inhaling harmful fumes. Use non-abrasive cleaning methods to prevent damage to the busbar surface. Thoroughly inspect the busbar after cleaning to confirm that all contamination has been removed. If there's any uncertainty about the busbar's integrity, it should be replaced. In summary, paint on busbars is a serious issue that can affect the performance and safety of electrical panels. Oil-based paints pose a greater risk due to their non-conductive nature, but water-based paints can also cause problems if applied excessively. Cleaning the busbars properly is crucial to remove the contamination and ensure the integrity of the electrical connections. Always follow safety guidelines and consult with professionals if needed to maintain a safe electrical environment. When it comes to electrical panels, busbars play a critical role in distributing power efficiently and safely. These conductive bars are typically made of copper or aluminum and serve as a common connection point for various circuits within the panel. Maintaining their cleanliness and integrity is essential for optimal performance and safety. However, situations can arise where paint finds its way onto the busbars, raising concerns about contamination and potential hazards. Paint on busbars can introduce several problems that can compromise the functionality and safety of the electrical panel. The extent of the contamination depends on the type of paint used and the thickness of the coating. Oil-based paints are particularly problematic due to their non-conductive nature. When oil-based paint coats a busbar, it acts as an insulator, impeding the flow of electricity. This increased resistance can lead to overheating of the busbar, which in turn can cause electrical fires. Additionally, the presence of paint can initiate or sustain arcing faults, creating a significant safety risk. Water-based paints, while less hazardous than oil-based paints, can still affect conductivity if applied excessively. Even a thin layer of water-based paint can disrupt the electrical flow, especially if it contains impurities or additives. Therefore, it's essential to address paint contamination regardless of the type of paint involved. Cleaning paint contamination from busbars requires a systematic approach to ensure both effectiveness and safety. Firstly, disconnect the power supply to the electrical panel to eliminate the risk of electric shock. Secondly, identify the type of paint present on the busbars. This information will help determine the appropriate cleaning method and materials. For oil-based paints, use a solvent or paint remover specifically designed for this type of paint. Apply the solvent to a clean, lint-free cloth and gently wipe the painted surfaces. Avoid using excessive amounts of solvent as it could damage the insulation or other components within the panel. For water-based paints, a mild detergent mixed with water is usually sufficient. Dampen a clean cloth with the solution and carefully wipe the affected areas. After cleaning, inspect the busbars thoroughly to ensure that all traces of paint have been removed. Look for any signs of corrosion or damage that may have been caused by the paint or cleaning process. If necessary, use a non-abrasive brush or pad to gently scrub away any stubborn residue. Once the busbars are clean and dry, it's essential to verify their electrical conductivity. Use a multimeter to measure the resistance between different points on the busbar. The resistance should be minimal, indicating a good electrical connection. If the resistance is higher than expected, it could indicate that there is still some contamination present or that the busbar has been damaged. If the busbars are severely corroded or damaged, it may be necessary to replace them altogether. Consult with a qualified electrician to determine the best course of action. After cleaning or replacing the busbars, it's essential to implement preventive measures to avoid future paint contamination. Firstly, ensure that the electrical panel is properly sealed to prevent dust, moisture, and other contaminants from entering. Secondly, avoid painting or spraying near the electrical panel. If painting is necessary, cover the panel with a protective sheet to prevent paint from getting inside. Thirdly, regularly inspect the electrical panel for any signs of contamination. Early detection can help prevent serious problems and ensure the continued safe and efficient operation of the electrical system. When considering the safety aspects of painted busbars, it's crucial to understand the potential hazards involved. Paint can reduce the conductivity of the busbar, leading to overheating and electrical fires. Additionally, paint can initiate or sustain arcing faults, causing serious damage and posing a significant safety risk. Therefore, painted busbars should not be considered safe until they have been properly cleaned and inspected. Water-based paints are generally considered less hazardous compared to oil-based paints, but they still require proper cleaning. If the paint layer is thin and does not significantly affect conductivity, it may be acceptable to leave it on after cleaning. However, thicker or uneven layers of paint should be removed to ensure proper electrical performance and safety. In summary, paint on busbars is a serious issue that can compromise the safety and functionality of electrical panels. Proper cleaning and preventive measures are essential to maintain the integrity of the electrical system. Always consult with a qualified electrician if you have any concerns about the safety of your electrical panel. Now, let's delve deeper into the technical aspects of cleaning paint from busbars and ensuring their continued safety and performance. The selection of cleaning agents is critical to the success of the cleaning process. When dealing with oil-based paints, solvents such as mineral spirits, xylene, or commercial paint removers are commonly used. These solvents dissolve the paint, making it easier to remove. However, it's essential to use these solvents with caution, as they can be flammable and harmful if inhaled. Always work in a well-ventilated area and wear appropriate personal protective equipment, such as gloves and a respirator. For water-based paints, milder cleaning agents such as dish soap or all-purpose cleaners are usually sufficient. These cleaners emulsify the paint, allowing it to be easily wiped away with a clean cloth. Avoid using abrasive cleaners as they can scratch the surface of the busbar. The cleaning technique is also important. Gently wipe the painted areas with a clean cloth dampened with the appropriate cleaning agent. Avoid scrubbing too hard, as this can damage the busbar. If the paint is particularly stubborn, allow the cleaning agent to dwell on the surface for a few minutes before wiping it away. After cleaning, thoroughly inspect the busbars for any signs of damage or corrosion. Look for pitting, discoloration, or other irregularities. If any damage is found, the busbar may need to be replaced. The use of electrical testing equipment is essential to verify the integrity of the cleaned busbars. A multimeter can be used to measure the resistance between different points on the busbar. The resistance should be minimal, indicating a good electrical connection. An insulation resistance tester, also known as a megometer, can be used to measure the insulation resistance of the busbar. The insulation resistance should be high, indicating that the busbar is properly insulated from other components. The importance of following manufacturers' recommendations and industry best practices cannot be overstated. The manufacturer of the electrical panel will typically provide specific instructions for cleaning and maintaining the busbars. These instructions should be followed carefully to ensure that the busbars are cleaned safely and effectively. Industry best practices, such as those published by the National Electrical Manufacturers Association (NEMA) and the Institute of Electrical and Electronics Engineers (IE), provide valuable guidance on the proper care and maintenance of electrical equipment. In addition to cleaning, preventive maintenance is essential to ensure the continued safety and performance of busbars. Regularly inspect the busbars for any signs of contamination, corrosion, or damage. Tighten any loose connections. Apply a protective coating to the busbars to prevent corrosion. Keep the electrical panel clean and dry. The consequences of neglecting busbar maintenance can be severe. Overheated busbars can cause electrical fires, leading to property damage and personal injury. Arcing faults can cause explosions, resulting in serious injuries or fatalities. Poor electrical connections can cause equipment malfunction and downtime. In conclusion, cleaning paint from busbars is a critical task that requires careful attention to detail and adherence to safety precautions. By selecting the appropriate cleaning agents, using proper cleaning techniques, and verifying the integrity of the clean busbars with electrical testing equipment, you can ensure the continued safety and performance of your electrical system. Remember to always follow manufacturers' recommendations and industry best practices. And don't hesitate to consult with a qualified electrician if you have any concerns about the safety of your electrical panel. By understanding the risks associated with paint contamination and taking proactive steps to prevent and address it, you can help to ensure a safe and reliable electrical environment. Let's explore some advanced techniques and considerations for ensuring busbar integrity after cleaning. One crucial aspect is the use of specialized cleaning solutions designed specifically for electrical components. These solutions are formulated to remove contaminants without leaving behind residues that could affect conductivity or promote corrosion. They often include additives that help to protect the metal surface and prevent future degradation. Ultrasonic cleaning is another effective method for removing stubborn contaminants from busbars. This technique involves immersing the busbars in a cleaning solution and subjecting them to high-frequency sound waves. The sound waves create microscopic bubbles that implode on the surface of the busbar, dislodging dirt, grease, and other contaminants. Ultrasonic cleaning is particularly useful for cleaning intricate or hard-to-reach areas. After cleaning, it's important to apply a protective coating to the busbars to prevent corrosion and oxidation. There are a variety of coatings available, including anti-corrosion sprays, conductive greases, and conformal coatings. The choice of coating will depend on the specific application and environmental conditions. Another important consideration is the proper torquing of bolted connections. These connections can cause increased resistance, leading to overheating and potential failure. Use a calibrated torque wrench to tighten all bolted connections to the manufacturer's specified torque values. Regularly inspect bolted connections for signs of looseness or corrosion. Thermal imaging is a valuable tool for identifying potential problems with busbars. A thermal imaging camera can detect hotspots, which indicate areas of increased resistance or poor connections. By identifying these hotspots early, you can take corrective action before they lead to more serious problems. In addition to thermal imaging, vibration analysis can also be used to assess the condition of busbars. Vibration analysis involves measuring the vibration levels of the busbars and comparing them to baseline values. Changes in vibration levels can indicate looseness, imbalance, or other mechanical problems. When replacing busbars, it's important to use components that meet or exceed the original manufacturer's specifications. Using inferior components can compromise the safety and performance of the electrical system. Ensure that the replacement busbars are properly sized and rated for the application. The proper grounding of busbars is essential for safety. Ensure that the busbars are properly grounded to prevent electrical shock hazards. Regularly inspect grounding connections for signs of corrosion or looseness. The use of surge protection devices can help to protect busbars from voltage transients caused by lightning strikes or other electrical disturbances. Surge protection devices divert excess voltage away from the busbars, preventing damage. In addition to technical considerations, it's also important to have a well-documented maintenance program in place. This program should include regular inspections, cleaning, and testing of busbars. The maintenance program should be tailored to the specific application and environmental conditions. Training is essential for personnel who are responsible for maintaining busbars. These personnel should be trained on the proper cleaning techniques, testing procedures, and safety precautions. Regular refresher training should be provided to ensure that personnel stay up to date on the latest best practices. Remember, electrical safety is paramount. Always follow proper safety procedures when working with electrical equipment. Wear appropriate personal protective equipment, such as gloves, safety glasses, and arc-rated clothing. Energize equipment before working on it whenever possible. In summary, ensuring busbar integrity after cleaning requires a comprehensive approach that includes specialized cleaning solutions, protective coatings, proper torquing of bolted connections, thermal imaging, vibration analysis, proper grounding, surge protection, a well-documented maintenance program, and trained personnel. By following these best practices, you can help to ensure the continued safety and reliability of your electrical system. These principles can be applied broadly,